What's up everybody, I'm Jason and welcome back to another video looking at the EOS R5C in depth. This time we're looking at controlling the LCD screen's brightness. Now as far as the hardware goes, the R5C uses the same LCD as the EOS R5, and I've already looked at the R5's display brightness in a previous video, so I'm not expecting much in the way of differences. However, hardware being the same, the brightness controls on the Cinema EOS OS are completely different. Unlike the R5, where you simply have 7 steps to control the screen brightness, the R5C gives you 101 steps, arranged from -50 to +50. But it doesn't stop there. There's also an LCD luminance setting that affects the LCD's brightness as well. In effect, you end up having 101 steps in 3 different ranges for a total of 303 possible settings. Now maybe this level of control is relevant for the displays that come with cameras like the C500 Mark II and its brethren, but truth be told, it feels like a bit overkill for the R5C. Now all that said, changing the LCD brightness on the R5C is a more complicated affair, even more so than it is on the R5. So before I jump into the testing, let's quickly look at where you need to go to adjust the brightness of the LCD. On the R5C, hit the menu button and then jump over to the monitoring setup menu. This is the 5th menu group in from the left, and it looks a bit like a tiny monitor. So on the first page of the monitoring setup menu, you'll find the LCD brightness controls. At the very top, you'll find the LCD brightness setting, and then third up from the bottom is the LCD luminance setting. Select the one you want to change, and then hit the set button, or tap the entry on the touchscreen, and adjust as needed. Okay, so with the settings out of the way, let's talk about how changing these settings actually affects the LCD's brightness. So I've tested my R5C similar to how I previously tested my R5. I established a pure white image on the camera's display ensuring that it's at the clipping point, and then measured the brightness using an X-Rite i1 Display 2 colorimeter and the open source Argyle CMS color management software to determine the brightness and color temperature. Only this time, I made measurements every 10 increments instead of at every setting, and repeated this for each of the 3 LCD luminance settings. So the first thing that jumped out at me in the testing is that the R5C can actually drive the LCD brighter than my R5 can. I measured the peak brightness on my R5 at 625 nits, while the peak brightness on my R5C came in around 720 nits. That's a 15% increase in brightness. Though having only tested one R5 and one R5C, I don't know how much of this is due to sample-to-sample variation, or whether this is a model-specific difference. I have tested identical model computer LCD displays in the past, and I have seen this type of variation, but to a much lesser extent than the 15% that I'm seeing here. Now, thinking about this, I probably shouldn't have been all that surprised. The R5C clearly isn't designed to prioritize battery life, and there's added separation between the LCD and the camera components for the cooling vents and active cooling. In short, there's less of a reason to limit power consumption by keeping the brightness down than there would be or is on the R5. Now, if I'd only known this when I was shooting in the snow with the R5C, I really could have used the added brightness. Now, the maximum contrast ratio achievable on the R5C is 1,000 to 1, or put another way, just shy of 10 stops. This matches the R5's display performance. And this brings me to the devil in the details. The LCD brightness setting doesn't actually adjust the brightness of the backlight. Instead, and somewhat oddly, it adjusts the white and black levels of the image, and as a result, changing the LCD brightness alters the overall dynamic range of the image displayed and not just its brightness. So with the LCD luminance and LCD brightness both set to 0, I measured the black levels at 0.22 nits and the white levels at 234 nits. This results in that 1,000 to 1 contrast ratio. Actually, it's just a bit above that. However, at the same luminance setting, if you turn the brightness all the way down to -50, the blacks don't get any darker, but the whites drop to only 78 nits. This cuts the contrast ratio down to 350 to 1. Likewise, upping the brightness to +50 doesn't improve the white levels at all. However, the black levels are raised to 30 nits. Thus, the contrast ratio drops to a horrific 8:1. In fact, because increasing black levels harms dynamic range much more than lowering the white levels does, even upping the brightness to a +10 setting dramatically reduces the contrast ratio from 192 to or from 1000 to 1 to 192 to 1. Now, on the other hand, increasing the LCD luminance setting actually does adjust the backlight level and therefore has nowhere near the deleterious effect on the image. With the LCD luminance set to 1 and the brightness at 0, the camera managed 0.52 and 514 nits for the black and white levels respectively. This yielded a contrast ratio of 988 to 1. A virtually indistinguishable difference from the 1000 to 1 that we saw with the luminance set to 0. Finally, fully maxing out the LCD's luminance to +2 saw similar performance. At brightness 0, I measured 0.69 and 723 nits for black and white respectively, yielding a dynamic range of 995 to 1. The takeaway from this is simple. If you need the LCD to be brighter, you're best off leaving the LCD brightness set to 0 and increasing the LCD luminance value. If the display is too bright, you can certainly drop the brightness using negative LCD brightness, but you should never use an LCD brightness setting above 0 if you care about the dynamic range that the LCD can display. Now finally, if you're wondering about color temperature, at a brightness of 0, the color temperature hovers around 6,500 Kelvin at all luminance settings. At lower brightnesses, so -50, the temperature does drop to a minimum of around 6,100 Kelvin. Now I know this kind of glosses over a lot of important detail on the color temperature performance, but I will be talking about color temperature in more depth in a future video on adjusting the color settings for the LCD. So that's the LCD brightness controls on the R5C in a nutshell. If you found this useful or at least interesting, let me know by hitting that like button. If this kind of thing seems like it's your kind of thing, consider subscribing if you're not already. Finally, if you know someone else who might also find this interesting or helpful, please share it. It helps them, it helps me, and it makes you look like a hero in the process. Best of all, it's free, so it's a win all the way around. And as always, thanks for watching, and I'll see you next time.